Okay, we're going to work on the last 2.5 pages of the Titanic tragedy. Okay, so we're going to be answering questions from one of these four, I guess there are um, these six tables. These are called two-way frequency tables. I'm not sure if that's what our book is going to call them, but you can write out two-way frequency tables as frequencies or relative frequencies. Relative frequencies would be percentages. So number one on page 3 said, what percentage of the people aboard the Titanic survived? So we have to look at the entire ship, and we look for the percentage of those that were saved, and we get 31%. Ouch. That hurts. They had lifeboats for just over half, and yet 31% survived. And has anyone seen the movie? No? You have seen it? Was there room on the door for Jack? Okay, it's a stupid movie. Don't bother watching it. Okay. So, what percent of the women aboard the Titanic survived? Somebody did a scientific, like some researchers got together and built a door and went and like recreated it, and these really scientific people declared no, the door would not have held Jack. This was a year or two ago that they did this. So, yeah. All right. Women, 74%. So, were women more likely to survive than men? Yes. So if I were to ask, is survivability dependent or independent on gender? Does your chance of surviving depend on your gender? Yes, it does. Otherwise, it would be 31% all the way around. Does that make sense? So 31% for the total, and then it would be 31% for the women and 31% for the men. That's not the case. Who were the most unlucky people? Crew members. Crew members that were men, especially. Okay. Did class affect survivability? So we would need to go up here. Okay, so you guys don't need to turn here. But let's do a couple quick calculations. If you were a first class woman, what is your chance of survival? That would be 140 out of 144. So if you are a first class woman, you have a 97% chance of surviving. Okay? What if you were a male crew member? 192 divided by 885. You have a 21.5% chance of surviving. Not good, right? What if you were a third class male? 75 out of 462. If you were a third class male, you had a 16% chance of surviving. Why is that? Any idea why it happened out that way? Why did women survive more often? Why did first class passengers survive more often? Why did crew and third class passengers not survive? Yeah. Have you guys ever been on a cruise ship? My favorite rooms in the cruise ship are the middle of the boat, front to back, the middle of the boat, side to side, and as low as you can possibly get it. Why? Because I get motion sickness and I'm cheap. Where are the expensive rooms? On top or on the edges, windows and balconies. So you can charge more for those. Where does the crew sleep? At the bottom, under the water, right? So under the water you have the engines. The engines have to be under the water because they're connected to the screws, which are underwater, and you need some weight down there. So the Titanic, I'm not sure if it was coal or oil fired, but either way, the fuel is heavy, and that's stored in the bottom. And then all of the fun stuff happens at the top. So the expensive rooms are on top or on the edges. The crew is away from the fun, so they're berthed down low. And it's just harder to get to the lifeboats when you're farther away from them. Why else might that be the case? Why did more women survive? Even if we looked at third-class women, so 20 out of 23. Oh, don't times it. So even the third-class women had an 87% chance of survival. Why is that? Women and children first, right? Okay. Could that thought have contributed to the third class and the crew not surviving? Who was helping load the boats? The crew, right? So they're filling up boats, and eventually there are no more boats and there are way more people. So they couldn't get there. If you watch the movie, I don't know if this is true or not, but if you watch the movie, some of the stairwells had like those accordion gates, like the metal accordion gates, and they locked it so that the third class people couldn't get out. I don't know if that's actually true. But yeah, societally, people of higher status think that they should get on the boat first, and people of lower status might agree with it. So there might have been a social aspect to this too, like let the fancy dressed people on the boats first. I don't know. It happened at night, so yeah, maybe some people never even heard about it, because they actually hit the iceberg and they kept going, like they didn't stop. They just kept sailing, like, oh, no big deal. And the Titanic wasn't supposed to sink because um, the the problem is once you get a hole in the boat, you have to patch it. But the Titanic had this really cool idea, and it was built so that the floors could be sealed, which a lot of boats had. So if the bottom starts to flood, you just close all the hatchways, and then the bottom can fill up with water, but nothing else can fill up. But the Titanic had a different system, an additional system, where they had vertical walls, and there were hatchways going in these directions. So yeah, have you ever toured a military submarine or an aircraft carrier or something, and it's hard to walk from one room to the next because they have these funny shaped doors? Well, they're seals. You can close them and then crank them down, and they're waterproof. So they got a hole here, and the idea was, oh, all we have to do is close these doors, and it the boat will be fine. And they just kept going. I mean, eventually they knew there was a hole there, but they kept doing it. But the problem was it filled up to the point that it spilled over into the next one. And once that happened, it was doomed. Like, I don't know if they didn't close the gates or what, but that's why they called the ship unsinkable. In fact, some people said God couldn't sink the Titanic. So there were three boats: the Titanic, there are two more. One of them became one of them might not have been finished, and the other one became a hospital ship in World War One, and lots of people ended up dying on it too, because they were It was a hospital ship for war. Anyway, so there are a lot of things we can do here. We can figure out what percentage of women were third class who died by doing 89 over 425. But we can also figure out if you were a first class woman, what is your chance of survival? And we did 140 divided by 144. Similarly, we could say if you were a woman who died, what is the chance that you were a crew member? So a woman who died would be this column, and then we would do crew divided by 109. 3 divided by 109. Does that make sense? So we did fill out a relative frequency table, but there's a lot of different ways that we can look at these depending on how we do our division. So, oh, is that you, Garrett? I don't know. Maybe it kicked me out. It did. All right. Okay, turn the page. So, on this page, so what does probability of A mean? So let's do probability of male. The probability of male means if you were to reach into the Titanic manifest and grab a random person, and again, we're just restricting this to adults, what is the chance that you pull out a male? How would you find that? All right. Okay, sorry, my mic died. Got a new mic. So you would take the total number of males and you would divide it by the total number of people. Okay? So how would you find the probability of crew? You take the total number of crew members and divide it by the total number of adults on the ship. That's pretty easy, right? Okay. Well, what if we did the probability of male or crew? So we would take all of the males and add them to all of the crew members. Is that going to work? So I would do males plus crew, but that's going to create a little bit of a problem. So let me look at the answers. Okay, entire ship. So I'm going to take all of the males. Oh, I don't have that here. How many males are there? Look back on the first page. There are 1,690 plus, how many crew members were there? 908. Is that going to be right? Well, that gives me 1690 plus 908. And I got 2,598. Oh, good. So there are only, how many total people are there? There are only 2,115 adults on the boat. So what do I need to do? I need to subtract off the male crew members because they got counted twice. Does that make sense? So how many male crew members are there? So we go back to males, and crew members are 885 minus 885. So we subtract 885, and I get 1,713. Okay. Now there's another way you could have done this. You could have, well, there's another way to do it, but maybe we don't want to talk about that. So this is the probability of male plus the probability of crew minus the probability of male and crew. And the reason we have to do that is if we have a Venn diagram and I have male and crew, there are 1,690 in this bubble, and there are 908 in this bubble, which means there are 15 plus 8, so 23. There are 23 in here, which means 1667 and 885. So when I add these two numbers together, those people get counted twice. So, or did I get that backwards? I got that backwards. Sorry. Anyway, this should go in here. 885 and 23. So the people in the middle got counted twice, which is why our number was so huge. So an OR, anytime you have a probability of an OR, you find the probability of the first one, and then you add it to the probability of the second one, and then you subtract off the probability of both, so that those people don't get counted twice. Okay. And then what is the probability of and? So there are two ways to write this. The probability of male and crew, or the mathematical way is the probability of male intersect crew. That's just the intersect symbol. Yeah, it just means intersect. You know, union means you put them together. The upside down union means intersect, which means both. So how do we find the probability of reaching into the Titanic and pulling out a random adult who is both male and crew? So we'd go back to the first page. How many male crew members are there? 885. And how many total adults are there? 2115. So it would be 885 divided by 2115. Okay? That's how you do an and. So in general, ands are bigger than ors. Or sorry, ors are bigger than ands. Okay. What about given? And sometimes it's written as P of male given crew. Okay. What this means is you're only allowed to look at the givens. So when this says, what is the probability of male given crew? We are going to reach into the crew members and find the probability of pulling out a male. So we're only allowed to look here. So how many total crew members are there? So that's going to be, total crew is going to be 908. What percentage of those people are males? It would be 885 out of 908. Okay, so let's do some more givens. What is the probability of first class given female? So there are 319 first class people. How many of them are female? 144. So it would be 144 out of 319. Okay. Okay. What is the probability of surviving given third class? So we're only allowed to look at the third class people. So that would be 627. And then we want to know what is the probability of surviving given third class. 151 over 627. Okay, does that make sense? All right, get to work.